my name is Jeremy Allison, and I work for Google in the Open Source Program Office, work on Samba, obviously, and there are way too many people in this talk. So this is probably the dullest talk at the conference, and I just want to point this out in advance. The genesis of this talk was a bug that actually was, unfortunately, and not assigning blame, but it was introduced by Volker when he was Volker was completely within his rights to point this out. He did a fix for a customer issue that broke something else that was very subtle, and I came in and sort of oh, okay, you've caused this problem, and fixed it. And Volker said, this code is too brittle, too fragile, and nobody understands it but you. You need to document this stuff. This is your fault. And he's completely right. So this is essentially an annotated code walkthrough of one of the oldest pieces of code in Samba. So anyone who doesn't work on Samba, internals, file names, or whatever, I'm pretty sure there's a really exciting talk going on next door. Because I don't want anyone to, unless, like Tom, you want to just fall asleep and have a restful session, that's fine. But yeah, this one is essentially drilling down into the details of what we do, why we do it, and how it got developed that way, and why it's a horrible mess that needs fixing. So, what's a file name? Yeah, well, that seems a simple question, until you throw in extra stuff like streams and symlinks, which are uglinesses that I will get to. So, I mean, essentially a file name is a reference to an object that you want to open or create, and it's separated into directory components. Now, what a file name looks like has actually evolved. Originally, in the very early stages, Core Plus, Landman, whatever, it was 8.3 file names. Now, the modern SMB3 is quite a flexible object. SMB1 is dead, and I'm really going to avoid covering the details of SMB1, and because essentially I want to rip that code out of the server, so I will only cover the details of SMB1 where it's relevant to our current SMB3 implementation. And you might say, why is SMB1 code relevant to our SMB3 implementation? But I will explain a little later. There are some things in the SMB1 code that we still use in SMB3 to perform features that are very hard to do otherwise. It sucks, but there it is. So on the wire, when you see coming across the protocol, you essentially see a UTF-16 string, 2 bytes per character, and it's I'm sorry? Little endian, yes, it's length specified, usually not null terminated. So on the server, in POSIX, Unix, Linux, it's a null terminated bag of bytes. And the only character that you can't have in the file name is a slash and a null, because the null terminates it and a slash is a directory component. Everything else is completely ignored. So some people might say, well, isn't it a UTF-8 string? No, it doesn't have to be. It could be any random set of bytes. Doesn't have to be any valid Unicode format. It could be in ShiftGIS or old different internationalization formats. It could just be random bytes that somebody created out of a randomizing algorithm. So file names on the server are essentially uncoordinated. So how do we treat file names inside of SMBD? Over the past 2 or 3 years, I did a lot of work. We were originally using just const char* C strings to pass file names around. And for modern SMB, for some of the things that we need, that's just not rich enough. You end up having lots of conversion functions that say, oh, is this a name with a stream in it? Oh, isn't it? And then you get past a string and you're not sure whether someone has already chopped off the stream information or not, and whether you need to put it back on. And so that code was just getting really ugly and complex. So we standardized on a structure that essentially is SMB file name, and everywhere in the VFS that you actually access a path name that exists on disk, you pass in and receive back struct SMB file names, and that actually makes the code a lot more useful for OEMs. So the components of that are reasonably simple. You have the base name, which is the file name on disk, which is relative to the current working directory. That's an interesting topic I'm going to go into in a little bit. Normally, that current working directory is the root of the exported share. It may be a component within a path name. Then you have the stream name, which is essentially checking if that is non-null, lets you know whether you're trying to access a stream-based file name. Then you have this legacy thing for SMB1, which I'm planning to get rid of, called original lcomp, which is basically, after case normalization may modify the file name, we store, for legacy reasons I'm going to figure out and remove, we store the original case of the passed-in file name. Then we have a set of flags, 32-bit flags field, which allows us to say what kind of file name this is, and I'll go into why that's important later. And then, if the file exists, we store with it a copy of the stat struct that you get out of POSIX kernel. So that enables us to do things like, well, does it have a link count? What are the Unix permissions? Essentially, it has all the attributes that we might need to quickly access associated with that file name. If the link count in that is 0, essentially if that struct is nulled out, then the rest of it is considered invalid, so don't look inside there. So we have a little macro that says is valid stat, that basically just takes the link count being 0. This is actually why originally I think in the Windows port of Samba onto the Unix subsystem they had, for directories I think the link count was being returned as 0, and that was one of the things we ended up needing to be fixed to allow Samba to work on the Windows Linux subsystem. So, yes.
How do you know the link count is 0 because it's not in the structure?
Well, it's inside the stat, the ST field. You've got an ST.
But the whole stat field is valid only if the link count is...
No, so the whole stat, basically you have a stat structure which is stored inside the file name struct, right?
Okay.
And then to check whether you should look at that, first thing you do is say if it's valid. You look at an element within it.
I'll just say you and go. You can go on.
Well, so when it's better than having a bool or something. When you initiate one of these, you zero it out, and only when the rest of it is valid do you actually store something in there. So essentially, that's a quick way of passing around metadata with the file name that you're going to need to access most of the time. Yeah, all right, you can say it's ugly, but it was very convenient, and it enabled me to collapse many calls that took 2 parameters, a const file name and a stat struct, down into 1. So that's...
What Tom might be saying is, just to make a feeble joke, I mean, if the struct stat thing is, it's only valid if something inside is set to 0. So if it's not set to 0, then the content is not valid.
Oh, you want a pointer there, is what you're saying.
The content...
Sure, it could have been a pointer.
Yeah.
Code style thing, and it was just an idle question.
No, it's...
Criticizing a thing.
Yes, you are, but that's okay. So, our main problem is we're given UTF-16 on the wire. No, valid criticisms like this are how we make our code better. That's a good point, and I'll take it under advisement, and I'm not changing it right now. That's too big a change to make, and it would mean a VFS ABI change, so maybe for Samba 5. So, how do we get from the UTF-16 passed on the wire to one of these? How do we go through the mechanisms of getting there? And it takes a boatload of steps, and you'll see why. So first, got to copy it off the wire. So we know it's UTF-16. We have a convert string talloc, which allocates the string as it copies it off the wire, and it converts it into what we call the Unix character set. Now, everybody, originally when we created that abstraction of Unix character set, there were still people using lots of, EUC, they were using ISO 8859-1-2, shift-JIS, whatever. Now everybody uses UTF-8, but the abstraction's still there, so usually it takes the UTF-16 and turns it into a UTF-8 string. We error out at that point if it's not a well-formed UTF-16 string. So that gives us a null-terminated string that we can process further. Now, if you're coming in on an IPC dollar, so you interprocess communications share or a printer share, we're done. Because those names are not processed further, they're just passed into connecting pipe names. That was a cause of a major bug a major security bug, but we'll gloss over that. Now it's safe, or passed into printer shares for print job names, we're done. So at that point, it's not used for any file system access. You've got a UTF-8 name, you're done. All right, step number 2, DFS. So we've got the character set, we've got the string, we've now got a UTF-8 string. Now we have to do DFS normalization. So in the SMB2 request, you've got a flag bit that says, hey, you've got a DFS path name, you need to look at it. They look like /hostname, /sharename, /path. We have a set of internal functions, resolve DFS path wildcard, which was for SMB1 DFS paths, DFS redirect, parse DFS path. If you end up with a referral to the same server, so essentially it's a DFS path that should be treated as though it were a local path, sort of, share name with the host name is you, essentially. The path, we strip out the last component, path, and we treat that as though that's what the client sent as the path name. Part number 3, sanitize the name. We have a function internally called checkpath syntax, and that ensures that the name is a well-formed SMB directory name request. So as with Windows, it allows both slash and backslash as path separators, but it always, the string it produces out of that is always slash separated. We have a function next code point that walks through the path one UTF-8 character at a time, that keeps the state we need. We actually will normalize dot and dot components. That was probably, I don't think they're valid now in SMB2, but in SMB, we use this same function for SMB1. In SMB1, you could send a path name with relative components in the path, and it would normalize it on the server, so we do that too. The restricted character set for streams is different from the restricted character set for file names, so that function also uses the work that Metz did to figure out what the character set restrictions were for streams, and we will, if we keep state to say, oh, we've blundered into a stream part of the file name, and we'll reject it if we find one of the restricted characters. And if we return internally empty status, okay, hey, we've got we're well-formed path name, we know that it's slash separated, we can do something with it relative to the base of the share. Oh, as a side note, this also copes with incoming POSIX path names for Unix extensions, but as they're not in the wild yet in SMB2, I'm not going to talk about that any further. So, snapshots. In SMB2, snapshots are very nicely coped with a create context. So you send in the time warp create context that says, hey, I want a file that accesses the file data at this date. In SMB1, that was done by embedding the snapshot into the path name. And the terrible thing about the SMB1 code is that you could embed the snapshot name anywhere in the path name, at the beginning, at the end, anywhere in between, and it would expect you to parse it out and keep the rest of it alone. Now, so we wrote the code that copes with this. It took us a long time to get right, so sometimes we would confuse it with DFS path names, sometimes we would, I remember, I think it was Christoph Schmidt helped me a lot with getting this stuff right. So we essentially canonicalized this. Now this is a legacy leftover. What we should really do is the SMB file name struct that I mentioned a little bit further back, that really should have a time warp token in there, a GMT time. And for a future revision of the VFS, and when we've got rid of SM, well, that's what we're going to get to. We're not there yet, but that's the plan, is to have a time warp token in there. So right now, and because we're still used to dealing with SMB1 legacy path names, we just canonicalize it so that the @GMT component of the path name is always first. So obviously, you've got to do the DFS normalization first, then you do the canonicalization. Steve, yes?
So, because I was looking at snapshots myself earlier, I got to wondering what would happen if you in SMB2 passed a snapshot path SMB1 style.
So the comment is, what would happen with SMB2 processing in Samba if you didn't pass a time warp token and you passed an SMB1? I believe that we would. That's a very good question I don't know the answer to fully. I know that we would not pick out, if you pass in a time warp token, it would put the time warp token as a path name at the front, and then it would probably treat the second component. It may blow up at some point and say, this is an invalid path name. If you don't send a time warp token and you just put it in the path name, I'm not sure.
And I'm also curious, the same thing in Windows. I'd be curious what Windows
does.
Yes,
that would be a good exercise to try in Windows. My guess is the SMB2 path name parser in Windows is separate and therefore may reject an @GMT, or it may just treat an @GMT as a regular component in the path.
Yeah, I'm fascinated about this because you can imagine weird apps and broken clients.
This is the kind of place that you look for weird server behavior and security holes. So it's probably something worth investigating. Just not right now. So current working directory. In Unix, CWD is per process. Linux has a really nice optimization where you can make current working directory per thread, but that's not in POSIX. So in SMBD currently, this may change going forward. It's not decided. There's some discussions going on at the moment with Ralph Metz and Volker. When we first get an incoming path name, we know what share we should be in. We set our current working directory to be the root of the current share, read off from the tree ID of the SMB2. And all path names are assumed to be relative to that base current working directory. So having CWD be process-specific means that you can't do clever tricks with changing working directories inside threads because you're going to mess up the whole process. If you have a Linux-specific module, you can get away with this. And so essentially, symlinks make this very difficult to get right because there are Samba configurations that people want to keep working that are essentially massively insecure. And they don't care about the data we have an option called wide links equals yes, which is probably one of the worst things we ever did. But what that means is you can put a symlink inside a share export that points outside of the share, and Samba will allow that and say, okay, I'm just following it. You told me to go there. You told me it was okay to go there. I'm going there. And there are people who have setups that they want to keep that working. It's off by default, obviously, so it can get a little complicated. Essentially, when you've got wide links equals yes, all restrictions on where you are in the file system go away, and your server is essentially insecure. But that's what they wanted it to do. Again, when we get rid of SMB1, it's probably going to be time to get rid of that option too. Or maybe I should just make it unsettable for SMB2. That would be another option. So then we've got a file name relative to the base of the exported share. So then we call file name convert, which calls into something called Unix convert after doing a bunch of processing. And this is where the magic happens. This is where the big path name walk takes place to find out if what you sent in really exists on the disk, or are you giving me something valid? Now that function takes a set of flags, UCF, Unix conversion function X, where X is various different flags options. You can look at the code for that. That controls whether you're being passed a POSIX path name, whether it can have a wildcard in it for the last component, all these things. So inside that function first, we canonicalize the snapshot path, so we make sure the snapshot path's at the start, as I mentioned. Then, and this is the large directory fixed normalization, if we're requested, if smb.conf says, hey, I don't care what the client sends me, I want you to treat all file names as uppercase or lowercase. That's the point where we say, all right, that's what they wanted, we're uppercasing the whole thing, or we're lowercasing the whole thing. This actually can be helpful if human beings are never looking at the file names on the file system, and you want to emulate Windows very well and quickly on a case-sensitive file system. If you normalize case, and human beings never look at the file names, and they don't care that they're always shouting and ugly, then that massively cuts down search time, because you don't have to do a directory search if you miss the case, the matching case. And then that's where we store off the original lcomp, which I should really look into and get rid of, probably soon. Then we look for the stream name. and we strip off the stream name, use it to check for stream existence once we found the base file. So we squirrel that away. At this point, we have an optimization, which is called the stat cache. Now, the stat cache is a case-normalized version of a passed-in file name mapped to the version of the file name as it exists on disk. So you can have a shouty file name, a/shouty/file name, which is stored in normal capitalization like a/capital S shouty/file name. And so if that path name has been seen before, what Samba will do is look in the stat cache and say, hey, has anyone seen a shouty file name? Is there a mapping for it? If so, the stat cache will pass back that normalized file name and say, well, this is what the client used before, and that we think that exists on disk. Go check it. So in the common case, which is a non-wildcarded name, we just call stat on the file name that came back. If it exists, hey, that exists. The path name's there. We're done. We don't need to do any searching. And then if we didn't find it and the stat is there with the name the client gave us, we store an entry in the stat cache. Then we do, let's say, build stream path, which puts the stream path back and then opens the file, looks for streams inside to make sure that the stream exists given the stream name. If the stream isn't found, we just set stat invalid and say, well, okay, the file name exists, but the stream doesn't, because they may be trying to create the stream. We don't know at that point. So a little more details on the stat cache. We use an in-memory mapping. Unfortunately, it's not shared between SMBDs. I thought about making this a shared memory area that other SMBDs could access, but to be honest, it's probably safer security-wise to have each SMBD keep its own separate cache there. Yes, Volker. Oh, I'm sorry. Yeah, sorry.
I thought about that too, and our GAN cache right now is very fast, so we could do that. Mm-hmm. We do a stat after looking at the stat cache anyway, so I don't think there's really an information leak. And because we do the stat, which is then bound to the local permissions after that anyway. So we could do that.
Okay, so that's another, Volker's comment is, you're wrong, there isn't a security leak there because of the stat that we do. So yes, maybe, yeah, that, we have a gen cache function that uses shared memory. So yes, that might be a good optimization to look at. Okay, so if we find the match on the stat, we avoid the path name walk. Now, the nice thing about the stat cache is it can do partial walks. So if you've walked part of a file, if you get a long file name and the first 3 or 4 components match and the stat succeeds, then we'll overwrite the first 3 or 4 components with the correct case normalized version and then continue the walk from the rest of it. So it's not like you have to match the entire thing. You can do partial matches as well. So you only then search the remaining components. So it's a nice piece of code. It's old, but it's robust and works. So going back into Unix convert, stat cache failed. We didn't find it. The stat failed. So we've got to search. Now, when you're given a path name from a client, any component of the path name may be in the wrong case. So we have to walk down the directory tree, one component at a time, looking for the next match. Now we run into the ugliness of name mangling, which I'll get to in a later slide. So it's not as simple as, walk down a directory a component at a time. You actually have to check whether the name you were given is mangled and unmangle it, and that means some length processing where it gets complicated. So for each component, we call getRealFileName to see if the last component that we've chopped at the slash. So we're saying getRealFileName to try and figure it out if the last component exists. We have a strange case that a lot of people use Samba for, which is a Dropbox case, where the user has no access to a directory. They only have write access to a directory. They have no list access. So what they want to do is treat it as a Dropbox, where you drag and drop files onto this thing, and essentially they disappear, but they've been copied there. No one else can see them, and someone else can pick them up later. So we have a special flag for that case called which we only do if somebody's creating a file. So we know if it's an SMB1 or 2 create, so we add in a flag called prep create file. And in that case, if we get an e-access on the directory certs, we just continue and ignore the fact that we got the error and we keep going. Because it may be that it's the Dropbox case. So this has complicated some of the code a little bit. So we've got a component we want to check whether it exists on disk. We call into get real file name. And so what that tries to do is to say, okay, we've got this component, last component, let's see if we can find the correct cases that exist on disk. And obviously this is very painful because if you can't find it, you have to open the directory and search. So as an optimization into the VFS, a function was added, I think it was for GPFS, called get real file name. And what that can do is, given a file name of any case, the VFS can say, oh, they're asking for a fully uppercase name, but the way it's really stored on disk is, a camel case name or whatever. So at that point, we get the camel case name back and say, oh, that's what it is. We'll keep walking down the path. Now, that's an optimization that file system implementers have to add. By default, get real file name returns not supported, meaning, oh, the ext4 or whatever doesn't support it, go ahead and search. So at that point, you have to open the directory and scan through the directory a component at a time. And for a cache miss, so the client is asking for a file name that doesn't exist, and you've got a directory with 100,000 files in it, that means for every name that misses, you've got to scan that directory for 100,000 files. And we don't have leases on the directory from the kernel, so each time we do that, we have to scan the directory. So this is why Samba sometimes has the reputation of being slow when you get large directories. Unfortunately, there's no really good way around that other than doing the canonical case mechanism of uppercasing everything, and then you have ugly file names, but it's much quicker. So, mangling madness. Because of the Windows legacy on DOS, you have some restricted file names. You have, a file : name, aux : con : paths with backslashes in them. All of these are valid, paths with spaces at the end. All of these are valid in Unix and POSIX, but they're not valid over SMB. They're not valid on Windows. So in SMB1, what we did was mangle those names. So we have 2 mangling algorithms. It's pluggable, switchable. It's way too complex to go into right now, but essentially it will create an 8.3 file name for any name that can't be represented in an SMB name. It'll translate it into a representable 8.3 SMB name. When we went to SMB2, we reused that code for returning unit names to the client. We have it there. We have to have it there for SMB1. When we get rid of the SMB1 server code, what I would like to do is to change that to mapping the names that we can't represent as Windows, map the characters we can't represent in Windows into the private area in the UTF-8, UTF-16 character set. There's like a private area. And so you can essentially take any of those characters, map them into a character in the private area, and return that, because they are allowable as Windows path names. So that's what long-term I would be hoping to do. But right now, because we return 8.3 file names, which means we may get 8.3 file names back, what happens is for each component, if it's an 8.3 file name, we have to detect it. We say, is it one of our mangled names, which we can recognize? If it is, we then demangle it back into we have a cache and we demangle it back into its known component. So yeah, that complicates the code path inside Unix Convert, because it means a path can essentially arbitrarily change size halfway when you're going through walking down it. So we've done the path name walk, we've got something, so now we've got an SMB file name which we can return. So we do a valid stat, so that means that we fill in the stat struct and the SMB file name. It's got all the metadata that it might quickly need to access as part of the file name. If we're trying to create something, we basically null that entire struct out, so nlinks equals 0, which is how we detect that it's not a valid structure. And then we call something called check name. Check name does a bunch of things, but we have a concept of veto files in Samba, which are files that may exist on the disk, but the client must never be allowed to see. And you can do wildcards, you can do all sorts of different patterns in there. If it matches any of the veto files, we basically pretend that the file name didn't work and we don't allow it. And then we call VFS real path on the passed in file name to say, hey, where does this really exist on the disk? And that stops symlinks pointing outside of the share. And it says, okay, we're making sure it's under the exported share path. So in the end, after all this stuff, we end up with a validated path name relative to the share export path as a SMB file name struct. And so that's basically the details of how we convert this arbitrary UTF-16 string onto the wire into something that we can then pass into VFS functions and do useful work with. So in SMB1 and in my experimental tree that Steve referred to, if you have a Unix open or a Unix create context in SMB2, those Unix path names are flagged as UCF POSIX path names in going into Unix convert. And that turns off many of the features. So it stops looking for streams, it stops looking for name mangling, it treats case as canonical, what the client gave you is what you look for, and it's integrated into the main Unix convert code path. Now, in retrospect and moving forward in the future, I want to rip that out. Essentially, it should be a separate function. There should be a, hey, I'm a Unix path name, right. Here's a simple set of code that just does that, because otherwise you end up with a boatload of, if POSIX path name then do something different, and it complicates the whole Unix walk code, the Unix convert code. And so again, that's a fix that I intend to make moving forward. Just to make sure that the problem with that is we'll have some of the same logic in two places, but it should simplify both functions to the point that people can understand it and make changes to it without running into bugs. And again, of course, you have to do LSTAT for Unix extension names because clients should follow the symlinks, not the server. So it is, the VFS now only takes SMB file name structs. The nice thing about it is that it is still a little complex because you're pushing some of the complexity into the VFS for people to cope with. But it does mean that if you have a special feature that you want to add to a file name, to a path name in your VFS module, you can basically extend that SMB file name struct and add your own bits into it. You can essentially hide that fact from the rest of Samba. We don't really touch anything else in there. Yes, but for a custom OEM having their own custom version of Samba, they don't care about our ABI. They can do their own. They can make their own change. So this is basically previously when we were passing in char stars there, we were passing C strings in there. There was no opportunity to add any extra fields. Now at least you have something you can put your extra fields into. So the details of the path name processing unfortunately still bleed through into the VFS, which make it more complex than it should be. So you can't assume in the VFS that all path names are relative just to the root of the share, because we're doing symlink race hardening, and we're continually doing that. We're passing in more SMB struct file names that are a single component name, and you have to remember that CWD plus the name is where you really are. And the other thing, though, if you're working with this code is any path name processing utility function you might want, like find me the stream name, is this a stream, get me the parent directory relative to so-and-so, split this into what, we've got all of those functions. Somewhere in the Samba code is the function you need. I've seen many VFS authors who've written something and they say, oh, I have to do my own parent find, and I'm like, no, you don't, it's there, it's in a utility function. Anything you could possibly have thought of having to do with a path name, we've already had to do it, and there is a function there to do it. You just have to find it. So, where are we planning to go? Get the extensions upstream. The nice thing about that is one entire class of attacks against Samba as a server will disappear. I'll talk about that a little more tomorrow. Once the SMB3 Unix extensions are upstream, it means that clients will no longer be able to set symlinks on the server that the server follows, Because in the SMB3 Unix extension, symlinks are stored as reparse points, which are extended attributes on a file. Refactor the POSIX pathnames code, kill SMB1. Kill SMB1 file server. Just get rid of it. This leaves us with the problem is we have a boatload of SMB1 client code that we will have to maintain. How do we test that if we kill our server? My current ideas around that are essentially we freeze Samba 4. Whatever it is as the last SMB1 supporting release, and when we've got the Unix extensions in and we ditch the SMB1 code, we call that Samba 5. I don't know what the rest of it will look like, but that's what I want to call Samba 5. And, we're in the process of doing this right now, breaking the current working directory equals root of share assumption. There's too much code inside Samba that makes that assumption, and it's not valid, and we should stop doing that. So make it code fully with arbitrary CWD, and we're partially there already. I would love to be able to start spinning off threads that can change their own working directories and do clever things inside there, but I don't know whether FreeBSD does this. Does anyone know? Does FreeBSD have per thread current working directory? Anyone? Met says it does not. So yeah, life would be really simple if Samba was the Linux file server, but unfortunately we can't really get there yet. And Solaris just refuses to die somehow. I think the rest of them are all dead, but Solaris is the one that it's like a vampire. It keeps climbing back out of the grave. So, in conclusions, our code sucks. File name processing is way too complex, easy to put bugs into, and required this talk, which, yeah. Too much is done in two functions. The functions are too big. The code needs refactoring. It needs simplifying. Make the code better. Yes. Much of the problems in the path name processing code come from having to deal with SMB1. And also ugliness like having to deal with wildcards. SMB1 sort of explicitly says, oh, you can have a wildcard rename. And, just get rid of that stuff. Just remove it. The only wildcards SMB2 has is, I think you can have a wildcard when you're opening a directory and you're searching a directory. I think that's the only use of a wildcard in SMB2. I don't think anything else uses wildcards. Thank God. Now, having said that, I can blame the protocol here because it would have been very nice for SMB3 to essentially mandate that clients walk the path name they want component by component. Yes, it's a nice optimization to say, oh, here's a long path name, give me a handle to the end of it. But in terms of server hardening and simplification, it would have been really nice, and I believe the Linux client does this, if it forced you to open a handle for each component of the path name as you walked it. If it did that, much of my problems would have gone away, and I wouldn't have to do all this crap.
It's not expensive enough for you as it is?
Well, so the comment from Tom is create is too expensive. That would make it worse.
A lot
yes.
worse. A lot worse, right?
I'm sorry?
A lot worse.
Well, not necessarily, because remember, a well-written client caches those directory handles.
Yeah.
So whenever you're going into a directory, you should have a handle somewhere cached with a lease on it that you can reuse. It's very rare to... you normally get to one path, you get to one directory, and then you're continually working in that directory. It's rare to be skipping around.
That's true.
So, I believe NFS does this, that you have to walk component by component.
Oh, yeah. All walking is done on the client.
Yes, and I wish SMB3 had done the same.
Yeah,
I see why you didn't, but it would have made my life a lot easier. And if you ever do an SMB4, please do it that way. Not that you're going to, but that's just my feedback on the design. And the other thing I'd like to whine about is streams and symlinks are a disaster in terms of security and complexity, and they should die, and never have been born. For symlinks, I can blame LSD and Berkeley. Sorry, Tom, yeah? For streams, I blame Microsoft.
I'm not allowed to open my mouth till I'm on the object.
Okay.
NFS fixes that by parsing symlinks on the client, right? So it walks every component.
So the comment is that NFS fixes it by parsing symlinks on the client. However, user space NFS servers, if clients can create symlinks that server processors can follow, has the same problems that Samba does. Because you've created a real symlink server object. And I'm pretty sure if someone kicked Ganesha as hard as they've been kicking Samba, they would find symlink races in Ganesha too.
Okay. I could agree with that.
Yeah. So you can only get away with saying, oh, that client should follow the symlink if you're in kernel and you can explicitly not follow symlinks.
I mean, the trick you're trying to prevent is to cause the server to chase something.
Yes, exactly. Which is very hard. I mean, I know all the techniques for doing it. And the other thing is there is a flag within POSIX called OhNoFollow, which is singularly useless. It is the worst named pathetic flag you might possibly imagine, because it just doesn't do what you want. So you give it a long path name and you add, I've seen people make this mistake actually in code. You give a long path name and to open, you say, oh, and I want OhNoFollow, so I'm safe from symlink races. And of course, all OhNoFollow means is, oh, the very last component, the last thing you want that you don't really care about that much, whatever, don't follow symlink on that. All of the rest of it, hey, I'm following symlinks, I'm going to temp, I'm going to /etc, I'm going to /secure database, you name it, I'll follow it. And then the last component, it says, but the last component, the one that you're pretty sure is already there, well, that can't be a symlink. Oh, great. That's just what you wanted. So,
Jeremy, I'm afraid we're running out of time.
Okay, I'm running out of time. I'm sorry. There was a question there. Yeah.
Actually, now I have a new question. Did you look at the new flags, lookup flags, also coming from Google, from Android, I think. I think there may be other don't follow flags there.
Yeah. So I know there's a discussion on the Linux kernel mailing list for an OhNoFollow, this time I mean it flag. But the problem is that's Linux only, and it's not going to be in any kernel that we can.
So one question regarding the case insensitive. I just got an email from ext4 maintainer this week saying about ext4 case insensitive feature. I didn't think this would be that common, since you can certainly run Samba without the new file system feature. Samba has lived without it for over a decade.
Well,
you should have a chat with Ted to explain how much Samba does need that.
Ted knows. Ted knows. He knows what we have to do. Basically, it's really hard to do in kernel space.
So why doesn't he think people will use ext4 case insensitive with Samba?
So many of the Samba vendors and OEMs are using XFS, and XFS has a case insensitive setting. So they're already using it with XFS.
Without Dcache, so it's not performing well in Linux anyway.
Okay, yeah. So I mean, no, Ted works. He's on the East Coast. I'm on the West Coast. But I can
have a chat with him to explain. Yeah, people are going to use ext4.
No, he knows how much I need this. But then again, he also knows how much I need Rich Ackles, and he's not helping with that either. So was there someone else? Andreas?
I want to say for implementing case insensitive. There's another way to do it properly without file system support, but if there's no time, we can chat about it later.
Yeah, let's chat about it later, because this was the only way I could think to do it in the Samba.
You said it can be simple if people don't need to list the files.
So they can list the files
other than Samba list the files.
No, they can list the files. They just look ugly.
I know.
Yeah. No, the other idea someone had was store the real file name in an EA. Yeah. Oh, okay. Right. Yes. We know about that. Yeah.
Okay. Thank you very much,
sorry.
Jimmy.
I'm sorry. I'm being kicked off stage. Help. Well, thank you very much for listening. Thank you.